Good evening, children. This is the continuation of a second chapter. I hope you would have done all the homeworks and the sums that which I have done in the same class, same notebook, right? Please try to maintain the classwork properly. And today we are going to see few properties as well as one definition related with complex number. The first one is conjugate of a complex number. Many definitions we have seen using complex number, right? For example, how to find additive inverse, how to find multiplicative inverse of a complex number, and all we have seen. What are the properties of I that we have seen in the earlier classes. In this class, what we are seeing, we are going to see what is conjugate of a complex number. Again, z is equal to a plus ib means it is a complex number. If I put z, how to read this? Z bar. This should be read as z bar. Meaning is conjugate of z. If we put a line above z, it should be read as z bar. In additive inverse, we have seen a line before z, that is called minus z. That is called additive inverse. This is read as conjugate of z bar. What we have to do is just change the symbol of imaginary part. Don't get confused with this with additive inverse. Additive inverse means what we will do, we will change both the symbols, real part as well as imaginary part. But in this conjugate z bar, what we have to do, we should change the symbol of imaginary part. A plus ib means z bar is a minus ib, right? We should not change the symbol of real part, only the imaginary part's symbol should be changed. That is called conjugate. Then this z bar is called the conjugate of z. We're able to understand if z is a plus ib, conjugate is written as z bar, the answer is a minus ib. Okay, we will see few properties of this conjugate, complex conjugates. We are going to see few properties of complex conjugates. You see this z1 plus z2 the whole bar. How I am reading this? Z1 plus z2 the whole bar. Whole bar means total conjugate. Can be splitted like this. Similarly, z1 minus z2 the whole conjugate can be splitted like this. Individual conjugates. Similarly, multiplication z1 z2 whole conjugate can be written as individual conjugates. Z1 bar is into Z2 bar. Same way, for division also we can say this. Z1 by Z2 whole conjugate is written as Z1 conjugate over Z2 conjugate, or Z1 conjugate by Z2 conjugate. Another thing, if I write RE of Z, I should read this as real part of Z. This is read as real part of Z. The formula for finding real part of Z is Z plus Z bar by 2. Formula for finding real part of Z is Z plus Z bar by 2. Again, imaginary part of Z can be written as Z minus Z bar by 2i. Here it is 2, here it is 2i. Imaginary part means 2i will come. Numerator minus sign. There only 2, numerator plus symbol. Z power n, the whole conjugate is split, can be written as Z conjugate whole power n. Conjugate and power can be interchanged. And these are all few properties that we are going to see, that we are seeing now, which will be helpful for doing the coming exercise. So please, actually it is not over here, few more is there. So these are all what properties of complex conjugates. You have to write these things, everything in your classwork, and you should read this and memorize these properties also. If z is a plus ib, conjugate, this is read as z bar, meaning is conjugate of z. How to write? Change the symbol of the imaginary part, a minus ib. And these are all properties, nothing but This is plus, this is minus, and this is multiplication, this is division. In addition, subtraction, multiplication, division, complex conjugates can be splitted like this. And real part of z, the formula is z plus z bar by 2. Imaginary part of z, the formula is z minus z bar divided by 2i. And power and conjugates can be interchanged. That is what this formula gives the authority for us. Okay, now we will see few more properties. That is property number 8. Already we have seen 7. This is the 8th one. This is another important one. If z is real, if and only if z is real, if and only if z should be equal to z bar, only when the complex number is equal to its conjugate, then z can be real. These are all the conditions that we will apply in the problem. So memorize this also. Don't memorize, just understand. If z has to be real, real means what? Only real part should be present, imaginary should not be there. Imaginary unit I should not be there, that is called real. If z is real, the condition is only it is possible when z is equal to its conjugate, z bar. And another thing, 9th property is z is purely imaginary if and only if z should be equal to negative of its conjugate minus z bar. So these are the two properties of finding what we can use this and say z is real. If this condition is there, we can say z is purely imaginary. Again I repeat, if z has to be real, we should prove z and z bar are equal. If z is purely imaginary, we should prove z should be equal to minus z bar. And the final 10th one is z bar, the whole bar, is again equal to z. This you have learnt in your set language also. Z bar whole bar is equal to again z. And in another note, standard form, you know very well, standard form means a plus ib, is also called as rectangular form. Standard form a plus ib is also called as rectangular form. Standard form, rectangular form, both are same. Standard form of a complex number means we should write the complex number in this format, a plus ib. Rectangular form is also nothing but a plus ib. So these are all the things that we should know for doing the coming exercise. The next the coming problems will be based on these properties. So what you have to do is, after completing the previous thing, you just write these things in your classwork, write neatly, use the black pen and blue pen properly, and read these 10 properties as well as complex conjugate, how to find complex conjugate, even including this note. This note says standard form and rectangular form are equal, they are same. It is nothing but writing the complex number in this format, a plus ib. So this is called standard form, this is called rectangular form. I think you will understand this. These are all nothing but properties of complex conjugates, 10. All the 10 properties, just try to learn this. And apart from learning, you should write these things in your classwork neatly, right? We will see in the next class. Thank you.